Hello everyone, class 12. This session is for you. Okay, and already one online class taken on this chapter. Today I will take the chapter on differentiation. Okay, already one class is taken on that, and on that day many students you were not present. I don't know why. You know your timetable, but still you are not joining the class, and every day the same thing is happening. Just before half an hour, one by one is leaving. Why you are leaving, that also I don't know. But still I have to make some videos on this chapter, because that day also many sums were left. Already we have started the exercise, but today I'm not going to start only from the exercise. Again I will start from the beginning. But don't think that every time I will start from here and from the beginning, and you will not attend the class. Okay, don't think that. Okay, anyway, just watch everything, all the videos on this chapter. So today our discussion is on differentiation. Now differentiation already we have started in class 11. Calculus part already started in class 11, and in class 11 we did what is differentiation from limit, and then continuity very less part we did. And then what is differentiation, that time it is already explained. And sums also were there that time. And here again differentiation is there, but not only that simple type of sums. Here we will discuss about the differentiation on different types of functions. Okay, and next chapter means after differentiation, this chapter we will start the second order. This is again first order differentiation. Second order differentiation is there, and but before second order we have to finish the first order differentiation. So now the different types of functions, differentiation on different types of functions. What are the different types of functions? And different derivative of implicit function, derivative, most of the sums we did in class 11 on explicit functions. Okay, so before that we have to just know what is explicit function and what is implicit function. So derivatives of implicit functions. Okay, now what is explicit function, we have to know at first. Acha. Now explicit function and implicit function. Explicit functions means to state clearly. That means to state clearly. Now the explicit function, this one is the function in which the dependent variable depends on independent variable. That means it is a function in which the dependent variable is expressed in terms of some independent variable. So if we write, say, y is equal to ax square plus bx plus c, we know this is dependent variable, and here x is independent variable. Okay, so what did I say? Here it is a function in which the dependent variable is expressed in terms of some independent variable. Dependent variable is expressed in terms of some independent variable. Okay, so we can write this, or we can write y is equal to e to the power x plus 1, or y is equal to log x plus 1, or y equals to log x plus e to the power x, whatever you want you can write. That is the explicit function. Now what is implicit function? Implicit function is a function in which the dependent variable has not been given explicitly in terms of the independent variable. Okay, that means it is a function in which the dependent variable is not expressed in terms of some independent variable. So we can write this as, say, if I write here, we have written dependent variable in terms of some independent variable, but here we cannot write in that way. So function of x and y, both the variables we can write at a time. So if xy, that means this is dependent and this is independent. This is dependent, this is independent. So we can write, so that means a mixed variable we have to write in one equation. So x square plus y square, say plus 2xy is equal to 4. Here it is written x square plus y square plus 2xy plus is equal to 4. That means x and y both written in one equation. Both written in one equation. So this is known as implicit function, where dependent variable and independent variable cannot be written separately. Here we have written dependent variable and this side it is written independent variable. That means dependent variable depends on independent variable. It is clear. But here it is not clear. Okay, that means x and y, both the variables dependent and independent, it is written at a time. In one equation it is formed. So this is known as implicit function. Okay. Now, if y is differentiable function of x, then the equation fxy is equal to 0. Differentiated equal to 0 is differentiated with respect to x, then the value of, from here what we will get, the value of dy dx is obtained by solving this equation. From here we can find the value of dy dx. Okay. Now this is the difference between implicit function and explicit function. So this part is now completed. Next coming, okay, next is derivative from parametric equations. Derivative from parametric equations. Okay, so let us suppose the parametric equation of a function is represented by x equal to ft. So let us write x equal to ft and say y equals to gt. Y equals to gt, where both the functions ft and gt are differentiable with respect to x. If the inverse function of x equal to ft, where t equals to phi x, is t equals to, say, inverse of this, t equals to, we can write phi x, then from y equals to gt, where t equals to phi x, then y is a function of, x. Y is equal to gt when t is equal to phi x. Then we can write y is a function of x. Okay. Therefore, dy dx is equal to dy dt into dt dx. We can write this. Therefore, how can we write dy dx? Dy dt means what? Dy dt means, from here, dy dt means g dash t. Okay, into dt dx. Dt dx means dt dx. Dt dx means what? Dt dx. Dt dx means we can write dt dx into dt dx is written, so we can write this as dx dt. This is into dt dx, so by we can write dx dt. Dx dt means f dash t, so we can write here f dash t. Okay, so g dash t by f dash t, where obviously we will write here f dash t not equal to 0. This is the derivative of parametric equations. Here parameter is t. T is the parameter. Okay. Next is derivative of inverse circular function. Inverse circular function, many trigonometric inverse circular functions are there. So coming with new video, inverse circular function. So there are sine inverse x, cos inverse x, tan inverse x, cot inverse x, cosec inverse x, sec inverse x, everything is there. So inverse circular function, let me make a new video. Okay, coming with new video.